Hello, everyone.
Hello, everyone.
We are thrilled to be here today, sharing our passion for Kotlin with you, and dreaming together, about the time that I think, thanks to the great Kotlin community, surely is going to come. The time when Kotlin will be the language, the one language to build them all, right? And as the saying goes, right, a dream that is dreamed together is reality. So let's make that happen. So in the agenda for you today, we have, first, we're going to describe this demonstration app we have. We call it Imaginate, that we use as like the test bed for all these cool features we're going to show. Then we're going to describe the Gradle Kotlin love story that makes this all possible. And then at the end, if we have the time, we're going to have this speed loop bonus for you and talk a bit about the configuration cache. So first things first, who are we? So I'm Rodrigo. I'm here with my dear friend Paul, and we've been happy Gradlers since 2015. In fact, I joined like just 1 week after Paul joined, and if you notice, we've been like switching team lead roles since then. It's basically how that goes. So you probably know that Gradle has a long history in the open source world, like building happiness and accelerating developer productivity. We are the makers of the Gradle build tool, as most of you might be aware. What you might not know is that we also have a product offering, Gradle Enterprise, which is the first tool of its kind. We call it a developer productivity engineering tool. And DPE is this like emerging practice, emerging software discipline that is about like making builds, tests, like all the development workflows faster and make problem research more efficient, right? So if you want to know more, please meet us at the booth. We can give you a demo. You might know the flagship feature of Gradle Enterprise, which are like the build scan, right? How many of you have ever tried a build scan? Awesome.
Nice.
Yeah, so for the other people who are now jealous of the smart people that already did, so you can use --scan when you run Gradle, and you see what it's all about. You're going to have a good introduction to this whole thing. And we also have this build speed challenge going on, so you can get some swag. So please just check the QR code later. And we also recruit, so if like building happiness and accelerating developer productivity, anything that we talk about here today resonate with you, talk to us. And then please, Paul, take it away.
Yeah, so we're going to take a look at this imaginary image generator. So, this is a Kotlin multi-platform application, right? And we're going first to run the web flavor of it. And it's compose HTML, right? And so it's pretty simple. You give it an API key. I'm going to use something silly for now. You give it a prompt, ask for an image, and of course, the API is wrong here, the API key. All right, so that was the web version. We also have the Android version. That is also using Compose multi-platform, but this time with some shared UI with another platform we'll take a look at. And then here, we can use...
Do you want me to type that for you?
Any prompt? Yeah, please, go ahead.
So
Try anything?
I guess I'll just try like, oh, it's still waiting for the device to come online. So I guess that's just a screenshot. You got me there, Android. So let's see. Well, while we wait, I guess we could
Look at
take a look at the desktop app then. That should be faster on this machine. Well, we are here. So thanks again, Android. So yeah, let's just try like an elephant in Kotlin Island. Did you know it's an island? I heard it's an island. Cartoon. Let's see what happens. Yeah.
Yoo-hoo, it works.
Cool. So we can now use the same logic, right, in the desktop app. But maybe this time you are more creative than I am. Any prompts you have? Anyone? Keep it safe, people. Yeah. This is a family event.
Fingers.
Rhino fingers? Rhino fingers, okay?
Let's try.
I guess that's it.
That's dangerous.
We'll see. Yeah. Oh my God. Suspense is killing me.
Okay, let's
Time out.
yeah, let's try again.
Try again. Yes.
Where are the fingers?
I guess he's doing like this with the ears, right? It's like, maybe like this. I can tell. Yeah.
All right, so we saw the three platforms that our app supports. And now we'll take a look at the code. So,
Do you want me to navigate for you?
yeah, sure. Please go ahead. And we start by looking at the desktop app that we just saw. So we start with the main function. And we can see here, like, if you're familiar with Jetpack Compose or Compose multi-platform, it's basically well-known stuff, a window, and the whole UI is in the app we can see here. And the app is just a regular Kotlin multi-platform UI. Let's take a look at where the app is used. So we can see it's used in the desktop main and also in the Android main activity. So the application is simple, right? But it's a demo, right? So we also saw the HTML version. So let's take a look at the main for the web app. And here we see it's about the same pattern. And let's take a look at what's inside the app. So we have some header, and then we have a switch, well, a when, between two states, like when we have an API key and when we don't. So let's take a look at the image prompt when we have one. And there is some...
Oh my God, it's full of state.
Yeah, a lot of state. And then the image generator, that's where the image generation happens, right? So it's still Kotlin, and it's our code to query the Stable Diffusion API. And let's take a look at where this is used, actually. And we can see this image generation KT file, where there is some usage, processing files, and it's a work action. And that's Gradle code, actually. So we navigated from the production code to build logic code here, and it's still Kotlin.
Yeah.
So we're gonna see next how this is done. And what we just saw is this: like we have our domain library at the bottom that does image generation, and we have both build logic and shared application logic that reuse it, and then the apps at the top that are built and reuse the shared logic. So next we're going to talk about the love story between Gradle and Kotlin that makes all this possible. And the first part of it is the Gradle Kotlin DSL. Gradle is a Java API. So the Kotlin DSL is on top of this and leverage Kotlin language features, such as the Kotlin scripting that allows us to have low ceremony scripts, and only official Kotlin compiler plugins. We'll see with examples how they are used. And all this to provide the nice ID assistance we just saw. And
yeah, so the way we structure this application, right, it's by using a Gradle feature called composite builds, right? So basically, we have 4 builds in the application. So you can think of them as kind of like independent or semi-independent builds in some cases, right? So we have the main application build that builds like the Android app, the desktop app, and the web app. And they share a lot of stuff, right? They share resources like these images that get generated. They share the main logic, as we just showed you, for like loading the image settings, like storing the API key using this great Kotlin library called multi-platform settings. Yeah, and then we have a build, another separate build just for the slides. So the slides are also part, like we build the slides in the same application because they also, as we're gonna see soon, share some of these same resources, right? And the other thing why we do that is that we want to isolate whatever we use in the slides from the main app, right? So if we're using libraries for the build logic, we don't want that to get in the way of the other build logic that we have for the apps. And then we have the build logic in BuildSrc. We're going to talk about BuildSrc soon. And the main library, like the domain library for this application, right? The image generation is in its own build as well. So it can be used from all these builds.
Wait a second. You said the slides are generated by the build using the image generation library, right?
I did say that.
Yeah.
Yes. So that's how we have this nice slide here, right? So, yeah. So we can see like capital K here. So this is a very cool Gradle font. I think we can use that on the next marketing material that we have to send out. And a beautiful picture of an elephant in the Kotlin Island by Caravaggio. You can see the play with light, right? Beautiful. So the way this works in let's say, Gradle terms, right, is that in the settings file, we basically include builds that we need, right, and set up the different projects. So this is the main build, right, the application build, and we include the build for image generation, we include the build for slides, and then in BuildSrc, where we keep the build logic, right, we also include the build for image generation. And you can see on the right the whole structure of the build. So I guess we go explore a bit more.
Yeah, let's dive. So, let's make some room. And then we'll, we should start where we were, right?
Do you want me to use the keyboards? We use different keyboard mappings.
Right.
I forgot to tell you that, sorry.
No.
Yeah, I'm more of a classical.
This is not Linux. I'm lost.
Yeah, sorry, man. So probably want to go to
image generation.
Yeah, image generation.
That guy.
That guy.
Yeah, that's where we were.
Cool.
All right, so that's where we stopped earlier when we explored the application, and we went from the domain library doing image generation to the build logic, and that's build logic. So let's see where this work action is being used.
Yeah, so we can click it here.
Yeah. And here we see we are in a Gradle task action. So that's the execution part of a task. Right? And if you scroll up a little bit, you see the inputs and outputs of that task declared. So it's regular Gradle. And yeah, one little trick here is that this task is actually untracked. You see the annotation? And that's because like the assets that are created during the build, the generated images, we store them in JIT, so we don't have to call the API on each build. And when we want to renew the asset, we just delete them and regenerate them. Yeah. And so if we scroll back down, in the task action where the image work is used, we see that we're using the class loader isolation of Gradle that allows you to, in a task action, use libraries in isolation during the execution. So the libraries you use in your task don't pollute the whole build logic. And so here we isolate the image generation library in this worker class path. So let's see where that leads us if we seek for usages. And we see a .gradle KTS file there. So this is the configuration of like the registration and configuration of the image generation task. And we see that the worker class path is set from the image generation class path. So let's see what this guy is. Yeah, so it's a regular configuration on which you will declare dependencies. And you will see just a little below, there is the image generation class path, libs, image generation.
Yeah, another cool thing I would highlight here is that, so we are in a KTS file, right? So this is a Kotlin script, right, that lives in BuildSrc, but we are using regular extension members, right, that live like in KT files. So that way you can share logic between your scripts or your plugins, right?
Yeah, and this one was made internal. It's in BuildSrc. It was made internal, so it doesn't leak to your project script, and you cannot use it by accident.
Yeah.
All right, can we go back to the task configuration? Oh, just a second. We see that like there is the image generation class path, but there is also other tools for which we declare dependencies because we have other tasks in that build. Because we turn the generated images into Android drawables. They can be shown in Android. Yeah, and if we look at the task configuration, there is another thing that deserves some attention is that task uses a service, and the service is named image generation semaphore. And that's because the API we use doesn't support concurrent access. So we have to like limit the concurrency of that task if in our build there are several tasks that run. And for that, we use a feature of Gradle, which is the shared build services. They are used to represent resources shared across a build. And you can like configure the parallelism of the usage from tasks. Yeah, and just above, so here we're going from the image generation and we're going up in the build logic, right? And here we see this custom DSL block, like comments, and here we're registering in extensions. And that's how in Gradle you do provide a custom DSL. So all this is happening in a .gradle KTS file, right? And this file is actually located in this SRC main Kotlin folder of BuildSrc. BuildSrc is a convention in a Gradle build. If you have a subfolder named BuildSrc, then everything that it builds will be available in the project scripts. And so here we have this .gradle KTS file. These are so scripts in source sets, and we call them precompiled script plugins. They end up being Gradle plugins, and the ID is actually the file name. You can use packages to organize them, but let's not dive into this. So let's see where this guy is used.
Here. Yeah. So here we're using that plugin, right? So and now we are actually looking, right? We're actually looking at one of our project build scripts, right? And you can see the contrast, right, between what we just saw in the convention plugin, right, where we had the imperative logic, the task wiring, configuring class paths, exposing DSL, and then in the build scripts, right, all we have to do is to declare, right, what we want our build to do. So that's the main idea here. And the features of the Kotlin DSL that make this possible, right? So this is pure Kotlin. We're using all standard Kotlin features. So this is, for instance, is a Java API defined by Gradle, right? You can see it's a Java function. And it takes this action type defined by Gradle, which is a SAM type, right? A single abstract method type. And if we go there, we can see that it has this funky annotation, has implicit receiver. What this annotation does is that it tells the Kotlin compiler to treat that type, that sum type, just like a type with a receiver, a SAM with receiver. And that's what the SAM with receiver plugin gives us. Another thing you can see.
Yeah, and the benefit of this is that you don't have to do it dot for each property you want to set inside that block.
And the other very cool feature that we can see here, right, is what we call static accessors. So these generated images, as you might remember, was like this dynamic extension that was registered at some point during the build. But then the Kotlin DSL actually generates statically typed accessors, like getters, that actually let you navigate this dynamic model. And the final feature we are seeing here, has just been recently introduced. And
it's still behind a feature flag, but it will be declared stable soon.
And this was a plugin that Gradle contributed to the Kotlin distribution that allows any code, any user code, to overload the assignment operator. So the actual type, right, of this prompt, width, height fields or properties are these Gradle API property types, right, that represent like reified properties. You can set value, get value, and they track dependencies. But now we can use those with a simple assignment operator. So what's next?
Yeah, we should go back to the slides. But the main oh no, we should take a look at, like, this is how we generate the resources, right?
Right.
Now we should look at how we consume them, like the web app, for example.
Right.
The web app build script. Not this one, that's the plugin. Yeah, the one there.
This one?
No, above, yeah.
This one.
So that's another project script, right? This time for the web app application, like configuring the build of the web app. And again, it's all declarative. You can see at the top that it applies one plugin. It's one convention plugin coming from BuildSrc that sets up all the plumbery. And here we have the dependency on the shared resources project we just saw on this shared bitmaps configuration that was created by our convention plugins. And all this is like static accessors now. And if we go down below, we see like the GS main Kotlin source set. We have an accessor to GS main. We don't have to use named or strings because it was actually set up by the convention plugin that is applied at the top. It created the JavaScript target for us. And then in dependencies, we see, again, a project accessor to shared logic and version catalogs for declaring dependencies where you centralize your version declaration in a TOML file.
So this is all generated, right? In more recent versions of Android Studio, at least, right? The latest
for now,
Giraffe. You can actually navigate directly, like, to the version catalog, and maybe we can show you that, right? I mean, the version catalog. And this is how we will actually define the dependencies. So it's a TOML file. And again, the Kotlin DSL generates the accessors so you can navigate using code completion. And there's a trick here, right? Like, whenever you see a dash, it becomes like a hierarchy in the navigation of the accessor, so you can use that to organize your dependencies.
All right.
All right.
So, to take a step back and recap a little bit what we saw, all this having Kotlin everywhere in your app, like from the multi-platform apps to the build logic, is possible thanks to the Gradle Kotlin DSL. And to have a lot of things statically defined in your build script, the Kotlin DSL generates that code from what the plugin supplied, changing into the Gradle dynamic model. Look at this, then generate the accessors so you can have them. And this is about like extension, tasks, projects, version catalog, like we saw. And that's why you get all the ID, assistance, and everything. The building blocks for which you will use every day to build your build logic, it's a lot of build, start with the convention plugins. That's the main thing to think about, like extract all your imperative logic and shared build logic in convention plugins. Convention plugins can use shared helpers, like regular Kotlin code, as you are used in your production code. And these convention plugins like create custom DSLs that then the project scripts use to declare the configuration, and that can end up with custom tasks using the worker API for isolation, like we saw, isolating tools, and bring some performance niceties like the parallelism of tasks.
Yeah, I guess here the main message, right, is you should keep imperative logic, right, out of your project build scripts. Move your imperative logic to convention plugins, or if you prefer to work like with Kotlin classes, yes, you're free to do that. Convention plugins have the benefit that they have, they do all the registration for you. So basically, the plugin ID is derived directly from the file name. So all you have to do is to put like a Gradle KTS file in your main source set for Kotlin, and you have a plugin, and you can start applying that in your build.
And you see, in that build is not large, but it has some complexity, and we already have a share of convention plugins, because we went all the way down of not repeating ourselves. So we have the Kotlin JS library, the Kotlin JS executable, all these are conventions. Kotlin JVM component, and then the main plugins like Android app, web app, desktop app, they reuse these other ones, their siblings. So BuildSrc, we've seen it so far, is like the way to share build logic in a build. But you could also extract all your build logic into an explicit included build, like not use BuildSrc, use the name you want, and do that. That's two ways. Like folks have been discussing the pros and cons. We have been discussing the pros and cons with folks, etc. And so we wanted to like explain a little bit what's the main difference between the two. So with BuildSrc, every code that is there is made available to all your project scripts. And you can directly use anything. So if you put a KT file with a const, you can use it in your script. Whereas with included builds, you declare an included build for your build logic, and nothing is made available by default. You would then have to declare dependencies. And there are two ways to do that. The first one is just request a plugin, and if the plugin ID is found in this included build, then it will be made available. It's dependency resolution behind the scenes, just like any dependency. Or you can declare a dependency. Like we did, we have in our BuildSrc that depends on our image generation. It's a dependency, a regular one. So since Gradle 8, there have been improvements in BuildSrc that make it much more like included builds, because BuildSrc predates included builds in Gradle, and now we are finally converging. And so our statement here and our recommendation will be start with BuildSrc. It's the easiest to set up, and move to included build when you need to. And another example, an example of a requirement for using an included build is exactly what we are doing here, like reusing code that is shared between the app and the build. Then we need to cut things apart, and then have the domain library in its own build so we can reuse it from both. Another use case is to isolate a portion of build logic. And isolating can mean isolating the dependencies, isolating its own build, or isolating the invalidation it causes when it changes and the rebuild. So if you start with BuildSrc, the transition is very simple. You only have to use convention plugins. If you start like from the build script, importing direct members, like you have a const and you use that const directly, then you cannot transition to included build without declaring dependencies with build script. It gets messy. So use conventions plugins only with build source, and you'll be fine if you need to transition to something more complex later.
It does get messy.
Yeah. If that gets messy.
Yeah.
So we have a number of resources. The slides will be available, so let's skip this. And we have time for our speed up loop bonus.
It's great. Yeah. So we've been talking about like how to organize build logic, how to structure your build, and how to write these beautiful KTS scripts that have static accessors. But the thing is, like no matter how well structured your build logic is, no matter how beautiful your Kotlin code looks, right? Running build logic takes time, right? And we have a saying in the configuration team, or maybe I just made that up, that the best configuration logic is the one you don't have to run, right? And that's what the configuration cache does. The configuration cache is a new feature being released just now that improves build performance by caching the configuration phase. I'm going to talk a bit about that. And then we can reuse that for subsequent builds. So here is just one of the measurements we made back then. It's a large Android app with 2,500 modules. You can see the difference it makes for the help task, because help is usually mainly configuration time, right?
Yeah, execution is really fast with help, right?
Yes. But we can also see the effect on an actual interesting use case, like a non-ABI change to some source file. Like we just change, have to recompile, and you can see the big drop in build performance, in build execution. These things are complicated. Yeah. So how does it work, right? So traditionally, you might have this mental model of the Gradle execution as having like these two phases, right, that are in green here. At least I think it's green. People told me it's green. I cannot tell. So it's configure and execute, right? With the configuration cache, the picture gets a bit more complicated, and we have to look at what's happening between configure and execute. So during this configuration phase, right, where Gradle is configuring the build, is loading all your build logic, applying plugins, building this model, that in the end produces like a work graph, right? So basically, together with your configuration model and the set of requested tasks, like that user requested on the command line or the IDE requested Gradle to run, Gradle builds this work graph by following test dependencies and all that, right? And then when the configuration cache is enabled, is turned on, what Gradle does is that it stores like this configured work graph to the configuration cache, right? And immediately discards all the state that it can discard at that point, like your configuration models that are not, used anymore, and like build services, basically releasing all the memory it can, right? And immediately loads from the cache again. So with that, we can then execute this work graph, but we can execute it better now with the configuration cache, and I'm going to talk about that in a minute. And in the next run, right, in all the subsequent runs, Gradle can simply start when the same set of tasks is requested, right, and when nothing has changed in your configuration logic, right? So as Gradle is storing the work graph, it's also storing like a fingerprint of all the configuration logic and all the inputs that are required. In case they change, right, Gradle can then run all the configuration again, so your builds are always correct with regards to the build logic, right? So in the subsequent runs, we just keep the whole configure, compute, store, and just go straight to the load and execute. So that makes builds much faster.
You said you could execute better. Why is that?
Yeah, so now that we store the tasks and loaded them from the cache, what Gradle does is that ensures that these tasks can no longer refer to each other. So the tasks are isolated from each other. So, and because they are isolated, Gradle can execute them in parallel, even when they're in the same project. So you might have enabled like the -- parallel Gradle option, but all you get there is like inter-project parallelism, right? So you have tasks from different projects, they will run in parallel. But with the configuration cache, we can run everything in parallel because we made sure there's no way a task will interfere.
No shared mutable state.
No shared mutable state. Yeah? And configuration time then becomes basically the time it takes to load the work graph. So that will vary, right, depending on how big your work graph is, like how many inputs, the size of the inputs. But that's usually much better than running all this configuration logic, right? And the other thing is the reduced memory consumption. Not only on the first run, especially on the subsequent runs, because we have no configuration phase, we don't have to load all that and discard, right? So things are much better.
In the first run event, there is memory consumption improvement because all the objects that are used to come up with a work graph can be discarded at that point. They don't have to leave the whole time of the build.
Yes, absolutely. So this feature just became stable in Gradle 8.1. That was released like 2 days ago. So turn it on, see what it can do to your builds. Expect that some plugins are still not ready because we just made the feature stable. Stable means we think it's ready for general use. We are committed to the API. We are committed to the behaviors, right, that happen when you enable the configuration cache. And now the community is catching up. We're working with our partners to make sure you have a great experience with Android, with Kotlin, and all that. So what's next, Paul?
Yeah, so after all that, we have more things planned in the foreseeable future. On the Kotlin DSL side, we have numerous usability improvements. So we want the DSL for interacting with containers to be much simpler because today there are so many ways to do the same thing. Rings a bell. So we want to trim that down. We also want to simplify, and we have a plan for that, the Kotlin and Kotlin DSL version management. Some folks have been struggling with this because when you want to use a more recent Kotlin version, you have to think what's the difference between the Kotlin version in your build logic, the Kotlin version to build your build logic, the Kotlin version to build your production code, and so on. So we want to make that simpler. We just published a new DSL reference for Kotlin, and it's like what we have now is so much better than we had before, but we want to make it even better. And a little improvements on usability. And of course, we have also some work on performance lined up. For example, the compilation avoidance, but for scripts. So that means if you have a setup like the one we looked at with BuildSrc and your project script, if you change anything in BuildSrc, it will recompile the script. And with compilation avoidance that's working properly, if you only change implementation details, not API, then script will not have to be recompiled. So that won't make script compilation faster. That will just avoid compiling script, which is even better. Yes. So we already have a plugins block interpreter, but it doesn't work in all cases. And the goal here is to make script compilation faster because BuildSrc, they have a preamble, which is the plugins block declaring all the plugins required, and then the body. And we do this in a two-phase compilation. And with this interpreter, we will not compile the plugins block, but interpret it, and it's quite much faster. Like our current interpreter brings a 20 performance boost on configuration phase when you have to recompile everything. So we want to make it work in all cases. We have some also tweaks to make building precompiled script plugin faster lined up. There is, of course, the K2 that looks very promising. So we are working with JetBrains to allow our script compilation to take advantage of it. We have some plans also to make first use faster. So first use is the first time you check out a project and you run that Gradle version for you.
Especially like the ephemeral CI use case, right?
And that the perfect example is ephemeral CI agents, where there is a fixed cost and we want to reduce that fixed cost. Yeah, and then we have some stuff around the configuration.
Yeah, so we really want to have the configuration cache enabled by default for new Android projects in the near future. So we're working towards that. And there's a new feature that is still like very much experimental. We're still experimenting with, but it's very promising. That's called project isolation, and you might hear more about that in the future. So yeah.
Mm-hmm. Again, if we talked about resonates for you, please reach out. We are recruiting. And that's all. Thank you very much.
Sure.
Yeah, we have 4 minutes for a couple of questions. If somebody have questions, you can ask.
If you have any questions?
Yeah, we have one.
Thank you for the talk. My question would be quite unusual. I wanted to ask about love. So we see that Gradle is great at building Kotlin things, but I wanted to ask how much Gradle with Gradle Build Tool and Gradle Enterprise product is committed to using Gradle Kotlin internally.
Can you repeat the question?
So the question is how committed Gradle is to using Kotlin internally, right? Yeah. So in fact, I'll just start saying that the configuration cache feature is implemented in Kotlin. Right? So
the Kotlin DSL is implemented in Kotlin.
Kotlin DSL is implemented in Kotlin. We love Kotlin. And if you ask me, but that's me, all new projects would be written in Kotlin. We are very much committed to always having Java-only APIs, so we get the most reach, right? So the APIs will always be Java first, but Kotlin, as you all know, right, is a great citizen of the Java land. So yeah, and with these plugins, right, that the compiler provides, we can make our Java APIs feel exactly like Kotlin APIs.
And Gradle plugins can be written in Kotlin, but they can be written in Groovy, in Java, any JVM language. And that's a strength also of Gradle. And so that's also why we want to keep our public API Java. But the implementation underneath can be Kotlin.
Yeah. Thank you.
Okay, I think we're out of time. Thank you very much.